All right, so in doing this problem, I'm going to have, this is a skater, and the skater has an initial speed, and then they're going to glide across the ice. So if I make the person on the ice, here they are, and they're skating, and they're just going to glide across the ice. Now, when they're gliding, there's only one force that's going to be acting on this skater, and that is going to be the friction in that direction. That's the only force that we have in the horizontal direction. So I'm going to label that as friction. We still have the two forces in the y direction that balance out. So we still have that the weight is down and the normal force is up. So those need to be labeled. So that's the weight and that's the normal force. Now what we know in the problem is the skater's weight is given as 615 newtons. So I'm going to put that right on the picture. Any facts that you know, usually we just put them on the picture. It also says that the coefficient of kinetic friction in the problem is 0.100. So we know that mu is 0.100. So that, what I have on the board, that's pretty much your diagram. Now it says find the deceleration caused by kinetic friction. So really the unknown is A, but because they are telling us it's deceleration, I expect that my answer for A will be a negative number. So there's the picture. So you can see I have only one arrow in the horizontal direction and two in the vertical direction. I still make my descriptive equations. So when I sum up my forces in the x direction, there's only one. And notice the person is going to move, the skater is going to glide this way, so friction is in the opposite direction. This is my positive direction. So this friction is a negative friction. So minus F equals ma. So that is your equation in the x direction. In the y direction, we sum up the forces, and it's not going to look any different than the other ones we did. Fn is up, so it's positive. W is down, so it's minus. And those two, again, they also equal ma. But what I'm writing on the board here, both of these equations are Newton's second law. That's F equals ma, and that's F equals ma. But we know that in the vertical direction, there is no a. So we can write it just as 0. So those are my descriptive equations. Now I just solve the things in the order that they can be solved. So what's the first thing I can solve for in this problem? I can solve Fn because I already know the weight. So Fn equals the weight. So Fn also equals 615 newtons. What can I now solve for? Okay, I could solve for the mass because I know the weight, so I could solve for the mass. So the mass is going to be W over G. Notice how I'm not doing it in red or blue because the mass is not a vector quantity. It's a scalar quantity, so I'm putting everything in red and blue as vectors on my picture. So that's going to be 615 newtons divided by 9.8 meters per second squared. And remember, a newton is a kilogram meter per second squared. So when you take a newton and you divide it by meters per second squared, you will get kilograms for the answer. What do you get for that? What's this? 62.8. All right, so 62.8. Now what can I solve for? Move this up a little bit. What can I solve for now? I can solve for friction using the formula that friction equals mu Fn. Because I have the mu and I have the Fn. So now I'll have the friction. So 0.100 times the normal force, 615. Don't need a calculator for that. It's going to be 61.5 newtons. So there's my friction. Now what can I solve for? Acceleration. That's the only thing left. If you look at the equation above, my descriptive equation, the x direction, I now know friction and I know mass, so I can solve for A. So I'm going to rearrange this equation to solve for A, and I'll do it over here. So A is going to be minus friction divided by m. That's where the negative is going to come from for the acceleration. The negative means it's decelerating, it's slowing down. So I'm going to get minus friction divided by m. So the friction is 61.5 newtons, and the mass is 62.8 kilograms. So looking at that, I can see that this number right here is a little bit bigger than that, so it's going to be if they were equal, it'd be 1. So it's going to be a little bit less than 1, so minus 0.9 something. And what is it? 0.9? What is it? 979? 0.979 meters per second squared. Again, you're taking a kilogram meter per second squared, which is what a newton is, divided by a kilogram, and you're left with meters per second squared. So that is the answer for part A.